webinar series that we are organizing. It's a pleasure to have you today with us on board. We will have through this hour 4 people presenting several approaches to this agri-food bio-based sector. Before we start, just a couple of remarks. This webinar is being recorded and it will be shared afterwards together with the presentations the speakers will be providing. Please, this is an interactive session, so the idea is for you to participate as much as possible and to ask your questions to the panelists through the chat you have on the bottom of your screen. For the speakers, please, your cameras and microphones switch off unless you are presenting. And let's go briefly through today's agenda. First of all, my name is Mariana Fernández. It's a pleasure to meet you all. I'm Head of Communications and Sustainable Innovations, and I will be moderating today's session. We will have as first speaker Angelo D'Amario from EIT-Food. Welcome, Angelo. I know you are now on screen, so a pleasure to have you today. He will be speaking about the agri-food sector in Europe. Then we will move on to the second speech of the day, the ECOFUNCO project. Patrizia Cinell from the University of Pisa will be in charge of that part. Then we will move to the next speaker. In this case, it will be the University of Almería, María José Lopez, professor over there, will be in charge of presenting the Recover project. And finally, José Mª Pinilla from NATAC Group will be speaking us about the bio-based food supplements per food. You will be maybe wondering why BioSuite is organizing these webinars. BioSuite is a Horizon 2020 project funded that aims to bring Europe to the forefront of the bio-based economy by encouraging and supporting brand owners from different sectors to switch to bio-based approaches. It's the consortium that is working to this purpose. Is made up by 8 partners, and it's coming to an end. This May it will be the last month of the project, but obviously we encourage you to keep posted, because we will be informing more about the next actions and about the project. And that's all from my side. Now I will leave the floor to Angelo, who will be presenting his part. Angelo, the floor is yours. I will stop sharing my screen and invite you to please share yours.
Yeah, thank you so much, Mariana. It's 11:05. I have 10 minutes and I have to be very, very fast. In the meantime, I have opened also the chat box. Can you see my screen?
Yes, we do.
Okay, perfect. So I have opened the chat box, and if you have live questions, please do not hesitate. I will try to reply them. Otherwise, I can provide you replies after by. So my name is Angelantonio. I work for EIT-Food. What is EIT-Food? It's the European Institute for Innovation and Technology. It's an EU agency based in Budapest, which is structured in cross-innovation communities. Yeah, and these communities, they have specific skills. So I'm working for the area of food, but we have also other kicks dealing with specifically with climate, mobility, energy, digital sector, raw materials, and manufacturing, for instance, also health. That's the first initiative bringing together the 3 sides of the so-called knowledge triangle, which is business, education, and research centers. And the aim is to increase the cooperation, the integration between the higher education business research. Let's say we are a little bit like the EU Silicon Valley. Okay, so today the scope of my presentation is to talk to you a little bit about the opportunities of the sector, of the food sector in terms of biofuels, coming also from the food sector. Food sector, it's not just about food. We have a lot of byproducts, and there is a big issue in terms of food waste, not only at EU level, but also at worldwide level. Let's start with one of the most actual issues that we have in the EU, the natural gas exported from Russia, and also the energetic crisis that we are actually living. So, natural gas in the EU, we have Germany, Italy, France, Austria, Poland, and Netherlands. And we can definitely say that we are within the most relevant buyers of this natural gas, which has a fossil origin. And this gas, as we know, has risen in terms of price, and the EU has also started since, let's say, the early year 2000 to find sustainable solutions such as biofuels. Another slide that I wanted to share with you is the trend of the different energy raw material used since the 60s, of the last century till today. And as you can see from these graphics, gas has represented together with the renewable energies, the only energy trend where we have a positive growth. So this is a relevant figure. And, something else that I wanted to share with you is that today we are depending up to the 56% in the EU on energy imports. The EU targets in terms of energy usage in transports by 2030 are equal to the 40%. Today we have already reached a good point, it's 10%. And in terms of biofuels, we are talking about 3.5%. But unfortunately, we have still the 0.2% of biofuels. This is pretty concerning, so it means that we have to do something. I've been in touch because today I've selected some best practices of the sector, some interesting projects, and within these we have the soft stock processing to produce biodiesel. This project has been developed by the Riga Technical University with the support also of the European Union to turn soft stocks, which are very difficult substrate to transform to turn into biodiesel, which is neither a product that can enter the food value chain, or it's pretty difficult to enter in the food value chain, but it represents a byproduct of the food value chain. So we are talking about a byproduct coming from the oil processing industry. Okay, so we can recover a relevant share of these soft stocks of the oil industry and turning it into biodiesel. It means a lot overall in this period of crisis. In addition, considering that biodiesel is actually produced mostly from cultures that are specific cropped for the purpose of creating biodiesel. In this case, we have also a convenience in terms of price of compared to the conventional oil crops for biodiesel. So it means that there is no competition within the food sector. I have reported also the context of this interesting initiative of the Riga Technical University. Please feel free to contact them if you want to know something else. And I would really thank the guys of the Riga Technical University that provided me with such interesting material. The name of the initiative is Biodiesel with 2S. Another initiative, which is part of the EIT food portfolio, is the Oleco initiative. Oleco is part of the ABP Food, mostly working in Ireland and in the UK. They sell oils, for Oreca, and then they recover also this oil after buy. So there are no wastes, no loose. And at the same time, they produce biodiesel, with this cooking oil. I have reported the link to a video, and I invite you to have a look after buy. This is another company which is in our portfolio. It's called the Microbiome, and they are based in Italy. They are a very promising startup. They do a lot of things on microbiology. So if before we have spoken about, let's say, biochemical processing of substrate, now we are talking about microbiological applications. In this case, Microbiome is very committed in microbial application to biofuels, but also to bioplastics and biopreservative. Their development branch, it's called green chemistry. One thing which is very interesting, and I would like to thank the guys of Microbiome for provided me with these materials, that now they are actually working on microbial fuel cells. So it's a new generation of battery where you use indeed you use bacteria to create a different in terms of potential. Please feel free to contact Microbiome. The link is reported in the title. Something about biomass state of play. I would like to thank Bioenergy Europe for their support in providing me with these figures. According to the International Energy Agency, there will be a relevant growth, and also the LIFE program is going towards that direction. So we have to keep our eyes open. There will be a relevant increase in terms of organic waste streams processing, and also in terms of forest and wood residues. This is very important overall when we are talking about heating and cooling, of course, because in terms of electricity, the market trends, they are much more focusing on solar panels. Something interesting is also happening for sure in the transport sector. The distribution of different biomass feedstock for energy 2019 is very clear from this graphic. Woody biomass is still relevant, but so when we do decisions, we are forced to think about woody biomasses. This picture, I wanted to share with you some figures about also the social sustainability of the biomasses. And we can see that in terms of renewable energies, biomass are also important from an employment perspective. We don't have to forget that. Finally, and I think that I'm very punctual for the end of my presentation. If you are an SME or a cluster operating in the bio-based industry, since this presentation is also in the framework of the bio-based industry, I would like to invite you to apply to the Empower Bio project, which is another BBI project. EIT Food is part of this consortium, and we are giving a free opportunity to SMEs and clusters to attend trainings, overall focus to overpass the so-called valley of debt, which is the first critical part of starting a company operating in this sector that could lead to giving up in terms of entrepreneurship. Yeah. So within these trainings, we help SMEs, but also clusters of SMEs to find financial solutions to bypass this very difficult moment. Yeah, the applications are still open, so please visit this website, and you will be part of our trainings. Yeah. For any further question, I'm always very open and happy to interact with you. And I've reported my LinkedIn contact. Yeah, please feel free to send me emails. And thank you so much for having provided me with this great opportunity. And I wish you a nice day.
Thank you very much, Angelo. Very interesting presentation. Please don't hesitate to contact Angelo and to visit the websites he just presented in case you are interested. Before moving to the next panelist, I will certainly invite you to connect with us and send us your questions through the chat function or the Q&A you have on the bottom of your page. Now we move to the next speaker, Patrizia Cinell from University of Pisa. The floor is yours.
Okay, I share my screen. Can you see my screen?
Yes, it's not still on presentation mode. Yes, there you go.
Okay, so good morning. Thanks for inviting ECOFUNCO project to this event. ECOFUNCO is a project based on the development of sustainable coatings. These coatings are based on molecules derived from biomass. So valorization of material coming from agri-food waste. So these agri-food waste are shrimps exoskeleton or mushroom sulfur, from which is extracted chitin, that is in part used as chitin or as chitosan. And while we investigated several biomass different types, such as tomato, melons, cantaloupe, watermelons, sunflowers, and so on, to extract from the seeds cutin and other active molecules. While from legumes, they were extracted proteins. So even here, several different types of legumes were investigated. This activity came even from previous European projects. Legumes were already investigated in the Edward project, as well as protein applied as coating to give a barrier to gas, especially in food packaging, keeping biodegradability and sustainability while achieving a highly performing packaging. Cutin was already investigated in some our project, and in Agri-Max project, which was a demo from BBI, was industrialized the extraction of cutin from tomato. While chitin has been investigated in several projects comprising nanoketo, pack polybioskin, and so on. So we merged the experience from several previous projects, and we promoted in ECOFUNCO the sustainable extraction of the molecules with innovative technology and green technology, and the use and valorization of these molecules for development of coatings. Coatings that were applied both on plastic and cellulosic substrates. The project accounts 17 partners from different European countries, including even 2 non-European countries, that were Turkey and Israel. We had a large participation of industry, very active even in the research activity. For example, in Belgium, Patrizia is a very active part in the extraction of the molecule, and in the production of nanofibrils of chitin, which were provided during the project. The University of Alicante was very active in the extraction of the molecules, while Fraunhofer, Stica, and University of Pisa were active in the application of a different coating. The idea was to achieve hydrophobicity through coating, barrier to gas through protein, and antimicrobial active properties through chitin and chitosan. And other functional molecules, polyphenols, lycopene, and other, with active property too. The target demonstrator were in healthcare products, such as tissue and disposable products as tablewares, which needs to be resistant to liquid food, so they need hydrophobicity, and barrier to gas and moisture for packaging of sensible food. For example, we had the prosciutto di Parma as an end user in the consortium, as well as large industries such as Huhtamäki Organic Chemia, producer of paper and cardboard items. So we selected some representative demonstrators in the packaging for sliced ham, which is very sensible to oxygen and to keeping moisture. The production of tablewares, which are very currently interesting topic because of the laws for replacing plastic single-use products, and the use of cellulosic tissue sprayed with chitin nanofibrils to be active on skin preservation. And we target to achieve good properties, so be able to realize, for example, the caps, which being based on cellulose and natural polymers will keep being bio-based and will keep biodegradability, which may be compromised if you coat the paper with polyethylene or polypropylene. As I said before, we had a large previous experience with partner Fraunhofer and partner Stica in previous project on the use of protein derived from whey or derived from legume as a very efficient barrier to gas. In the same time, we know that antimicrobial packaging is a rising importance market because the use of natural antimicrobial can limit the use of preservative in foods and the use of synthetic and petro-based, not so friendly-based substance to preserve the food from spoilage, especially easy perishable food. And wasting food is a huge waste of energy and resources. So the project now near to the end, it will end in end of July. And during the project, we have developed already most of the demonstrator, and we have created interconnection with bio-based economy since we valorize this very abundant biomass, which is based on waste and byproducts of the food industry. And also some more basic research was conducted at the University of Sheffield on the production of polydioxyalkanoates and bacterial cellulose from this biomass. So valorization of several different types of food residues and products which are very important in the plastic and cellulosic value chain. A technology for extraction based on critical carbon dioxide, microwave, ultrasounds, so all technology which try to limit the use of solvents and high chemicals. So valorization of all these biomass, the waste, even active biomolecules such as chitin and chitosan, but also the polyphenols and other molecules which are very rich in tomato, sunflower, cantaloupe, and melons in general. We've identified several biomass suppliers in Europe, and we achieved already a demonstrator with very nice properties of cellulosic-based ethers with hydrophobic properties and with barrier properties. These are very important in food, but even in agriculture and other sector. So we can close the loop of the food and the agro biomass, which go to produce our products sustainable that can be used in food and agriculture field. And we have achieved coating on cellulose substrate with different technology, including spray or application with lamination. And we have achieved several different plastic coated from the industry, which are plastic producers such as Biomin Croatia, Tipa in Israel, and Planet Bioplastic in Italy, which gave us the substrate and participated to the coating activity that was really supported by Fraunhofer, Huhtamäki, Organic Chemia. We already achieved almost most of the demonstrator, realizing coating with coating, heating, and protein, and then assembling heating, coating, protein, coating, heating, protein, coating, all the different combinations depending from the application. For example, when you have a paper cap, you don't need barrier to gas, but you need hydrophobicity, and you don't need antimicrobial. While in multi-layer packaging, for ham, you need all the properties, barrier to oxygen, to moisture, antimicrobial. So we have played with different combinations, all these demonstrator products. And this was, as I said before, connected even with previous projects, including Agrimax project. And we are always in contact with this spin-off company, Mª Paint, who is located near Mantova, who produce on industrial scale the coating, and we already had it validated as coating on metals, while in the ECOFUNCO project, the coating was tested and applied on cellulose and plastic. It was quite challenging, but we achieved some very interesting results. Now, answering to some of the questions that in play, what we see, the main obstacle to the transition from fossil-based to bio-based, putting this question to our industry, the consortium, we can say that what they express is that, of course, the cost of everything which is new is higher than the cost of everything that is already assessed from years. It is one problem that has to be faced to get a reliable and regular biomass supply. So getting regularly the biomass to be treated. The personnel sometimes needed to be more skilled because you are working with sensitive material, and sometimes you have to make new production lines or adapt your production lines. So everything of this is a cost. It's not always easy to achieve the same or better properties than the current PET or polluting solution, and to contain the increase of cost. This technology are new, are very performing, are very promising, but of course, being new, they cannot be cheaper than the current one. So you need to be supported. To be supported, for example, in a FIA LCA analysis, which is now not FIA, now is against bio-based products. And legislation and support to compensate this extra cost. So a help to be able to put your products on the market in a way that is competitive with current solution. So just to conclude, I invite you to visit our website for ECOFUNCO project, or visit us through Twitter or Facebook. And we will organize the final conference of the project in June in Pisa. June is a perfect season to come to Italy. There will be the feast of San Daniele. It will be very nice in this day in Pisa. This is a free conference, no fee, because it's covered by the project financing. And so you're very welcome to come to Pisa 17, 18 of June and present your project or just share with us your experience. And this is it. Thanks for your attention.
Thank you very much, Patrizia. Certainly an interesting presentation. I saw there was a question on the chat from Francesco. It will be answered once all the presentations are over and we have this special dedicated time frame for questions Let's move on to the next presentation. We will have on board María José Lopez from the University of Almería. So welcome, María José. The floor is yours.
Hi, good morning, everybody. Thank you to the organizer for inviting me. I will try to share my screen. Okay. Can you see it? Oh, it's...
Yes, we do.
Okay, thank you. Well, in this presentation, I will try to explain you what we are doing in the Recover project, which is also financed by the BBIGU. The main aim of this project is here we use a combined action of different enzymes and microorganisms, earthworms and insects, with the aim to clean up the plastic in agrofield, and also for the conversion of non-recyclable agri-food waste plastic streams into biofertilizer and bioplastic for agricultural and food packaging application. As you can see in the scheme that is in the slide, we use this mixture of different plastic that comes from the food packaging and also from the agriculture. And thanks to the action of those organisms, we will try to transform them into biofertilizers and also into bioplastic, mainly from chitin and chitosan that will be extracted from the insect, and at the same time provide an environmental eco services by trying to clean up the plastic contamination in terrestrial environments. The consortium that is carrying out this project is composed by 17 partners from 7 European countries, and it started on June 2020 and has a total duration of 48 months. It involves partners from the large company, SME, and non-governmental organization and association, and together with RTO. In the field of food packaging and agricultural end users and transformers, and also in the field of biotechnology, insect producers, and also earthworm producers. The objective of the project involves first the identification and the characterization of the problem that the agricultural plastic and also the food packaging that goes mainly to the municipal solid waste system, and also the microplastic in compost and also in soil. We try to characterize, quantify, and also define a collection strategy and treatment options for the further treatment using the combination of those novel enzymes that will be synthetic enzymes, microorganisms together with insect and earthworms that will be first selected, and then their combined production will be upscaled. We will use the microbiome inside of the insect. We will try to modify them, and also in the case of earthworms, but for the transformation of the plastic in those waste streams. And then once those will be upscaled and selected, will be tested, and they'll cross to real scale scenario, either for the bioremediation of soil that are polluted with plastic, or for the treatment of waste streams that can be will be transformed through the action of insects in insect rearing chambers, or in compost or vermicompost reactors. In addition, the value downstream products, including biofertilizers and chitin-based bioplastic, and will be chitin that will be extracted from the insect, will be used for the production of bioplastic that you can see in the table at the bottom, will be used for the production of different material for agriculture and food packaging, and also for the production of enhanced mulching films. Also, the sustainability of the process will be evaluated regarding the risk, safety, environmental impact, and also the cost, and including the logistic strategy for the collection, the treatment according to our solution, and a cascade strategy will be also proposed. And finally, of course, the impact in the social, the scientific, and economical impact will be evaluated. Here, as such, in Recover, we focus on the food packaging and agricultural sectors. Both consume around 44% of the production, worldwide production of plastic, and considering which are the current waste management system in which, especially for the municipal solid waste, in which the food packaging plastic ends. Only currently a small fraction of those plastic are recycled by conventional routes. In Europe, it reaches only 31%, but it is only 9% worldwide. It is because most of those plastic are composed by a heterogeneous mixture of plastic. Different type of plastic are mixed. Some of them, many of them are multilaminated, and also contain remaining of food or organic matter that prevent the recycling. And this is because they are or incinerated or landfilled. In this case, Recover will try to provide no new biorecycling routes using this combination of organisms and enzymes for its biorecuperation. Also, considering the fraction in this waste management system that is transformed by composting, for example, the organic fraction usually has also remainings of plastic that at the end goes to the soil. This together with the plastic that remain, for example, after mulching film removal, contaminated the soil. And also here, Recover aims to provide a solution for this contamination. Up to now, we have characterized the main plastic that can be found in the coming from the food packaging, in the municipal solid waste, and also in the agricultural practice. And we have characterized them, quantify them, and we selected the main plastic that will be used for the purpose of the project. That will be polyethylenes, polystyrenes, and polyethylene terephthalate. And in addition, we have also selected which will be the microbial consortia, the mixture of microorganisms, and also the insects. As you can see in the picture, there are evidence that the insects are eating the plastic, and also the earthworms are able to survive in the presence of plastic. We have selected them and tested in the plastic, and it is the combination of those biocatalytic systems together, the enzymes, the microbial consortia, the insect and earthworms, that will maximize the transformation yields, allowing the treatment of mixed plastic waste streams and convert the fossil fuel plastic into biodegradable counterparts in a single step. The contribution of the project to the bioeconomy, well, from one side, we aim to convert the agri-food waste plastic into chitin and chitosan-based plastic, a new fertilizer for the primary sector and bio-based food industries. And also we aim to establish a new circular cross-sectorial interconnection in the bio-based economy, which involves waste management and biotechnology. And we'll create 3 new effective bio-based value chains that will link the standard plastic with insect, microorganisms, and enzymes providers. And at the end, the final application sectors will be the farmers and the food manufacturer. So considering those, also the project has several benefits to the environment, including the reduction in the generation and dispersion of microplastic and increasing the plastic recycling with a new route in Europe by 12%. Aim to provide alternative for the removal of non-biodegradable plastic from the soil and the compost. Will close the loop within the agricultural and packaging sector by converting those waste into biofertilizer and bioplastic for agriculture and packaging application, and by avoiding the incineration in which most of those plastic are treated, will avoid the emission of CO2 around 80%. This is our aim. Here you can see the website and also the Twitter, Facebook, LinkedIn. Please check if you want to know much more about the project. And of course, here you have my contact. So feel free to ask me anything about this project. Thank you very much for your attention.
Thank you very much, María José. It was truly a pleasure to have you today. Let's move on then to the last presentation of the day. I will leave the floor now to José Mª Pinilla from NATAC Group. He will be showing us certainly a very interesting presentation. José María, the floor is yours.
Hello, thank you very much, Mariana, for the presentation. Thank you for inviting us to be here today in the framework of the BioSwitch project. I will also share my screen. Second. Okay, can you see?
Yes, we do.
My full screen. Okay, thank you very much. So, well, I will try to be brief today, and I will try to show you, let's say, a practical implementation of a bio-based initiative. I will give you a brief presentation of NATAC, who we are and what we do, and then I will move to one of our success cases in the framework of the bio-based industry in the valorization of agro-industrial biomass. So NATAC, we are a business group. We are dedicated to the research and development, manufacturing and commercialization of natural ingredients of botanical origin. So what we practically do is to extract and purify bioactive compounds from different plant and botanical matrices to develop ingredients for different sectors, mainly the nutraceutical, the pharmaceutical, the food industry, the animal nutrition, and the cosmetic sectors. Our, let's say, leitmotif is science to market, and our mission is to transfer the scientific knowledge to industrially viable and sustainable projects that create value and improve the lives of people. We are based in Spain. Our headquarters are located in Madrid, and then we have a production plant especially dedicated for the olive-derived products in Córdoba, in south of Spain. And then we have just built up a brand new factory in the town of Hervás in Extremadura that you can see here in the bottom right-hand photograph, which is a multi-product production plant, very unique with the last techniques for the extraction of our bioactive compounds. We have also a commercial office in the United States, in Salt Lake City, and we are opening a new office in Singapore for the Asian market. So what are our motivations to work with a bio-based industry? We are aiming to develop a sustainable strategy based in the following. We have seen, and we are all conscious, that fresh and processing industry of agricultural products generates from 25 up to 60% of unused biomass. This means that we are wasting natural resources which may contribute to the environmental impact and nutritional and functional waste. So we at NATAC, we begin with the evaluation and understanding of the supply chain, specifically the agricultural and industrial processing that use botanical resources to understand what points of the production process have potential for intervention. We are committed to designing circular bioeconomy strategies for each plant to upcycle plant byproducts as sources for botanical extracts and convert those resources into value-added ingredients that have an impact on people's health. Overall, this model leads to a more robust environment. So in a nutshell, what we are aiming to do in the bio-based industry is to use as raw material different agri-industrial byproducts that are produced in the industry, both by the primary sector and also by the manufacturing industry, and use those resources that are currently underexploited as raw material for the development of a new innovative functional ingredient for the different sectors that I mentioned before. Our business model is very innovative in our sector and is dedicated to convert all those different biomass as raw material for the development of these functional ingredients. So as you can see in the diagrams, we use all these agri-industrial biomass to produce our extracts. And then we are also aiming to achieve the zero waste approach by the upcycling and to take profit of also our byproducts that we generate. The main points of the model: we are specialized in different Mediterranean plants. We have control from the farmer to the final products, so we have full traceability of all our raw materials and products. We have a wide variety and large quantity of raw materials. We have products with different applications, both functional and technological, and we develop innovative ingredients with scientific support. And as I mentioned, we work with different biomass such as olive, artichoke, grape, saffron, pomegranate, and many others. I will now go briefly to present one of our success cases that has been the olive biorefinery. We have created the first olive byproduct biorefinery worldwide. So why olive? Well, obviously, olive is a key industry in Spain that allows us to differentiate in the global market. The olive biomass is located and available in one place, because as it's handled in Spain, all the olive oil industry biomass goes to certain operators that take value out of that. The biomass is available all around the year. This biomass management represents an environmental issue, so there is a need for the sector to take as much value as possible of all this biomass. And it represents Mediterranean diet flagship, which is very much appreciated in the health market. So it allows us at NATAC to go with the Mediterranean diet flagship in the international market. And finally, the olive, both the fruit and the leaves, are very rich in different bioactive compounds with very much potential for different applications. This is very briefly a diagram of the different products that we have developed out of the different parts of the olive oil biomass. So both from leaves and also from the fruit, from the pomace. So we have created, more than 20 different products out of the different biomass from olive, covering all the different sectors where we are introduced, like food, feed, pharma, nutraceuticals, different health sectors, both for animals and for people. And also what we do not use is still used to produce bioenergy by the biomass combustion. So this is just to showcase how an underexploited biomass can be used for different applications and different added value products, as we have also seen in the previous projects. Finally, I would like to share with you some keys and recommendations that we have faced during our strategy development that can be of help for anyone willing to go for the bio-based industry. First of all, and also Patrizia pointed out that before, it's critical, the biomass availability. So the availability of a certain biomass directly affects the viability, the amount available, its cost, and its location in reference to the location of the biorefinery are key factors to consider to find a feasible way of taking value out of those resources. So all about logistics is really a current pain point when someone wants to work in the bio-based sector. Secondly, what we call the real cost of biomass. So going from a byproduct to a biomass, so it's important to create value in the whole supply chain. It's very typical that when someone wants to use a biomass as a raw material, when a biomass is not used, so the cost is normally almost zero, one tends to think that it will be like this for forever. But when you give value to a certain biomass, then it starts to cost something else. And also you need to take into account things like standardization, logistics, and different key points that tends to increase the cost of the biomass. So this has to be taken into account when one wants to build up a bio-based approach. Then considering the collaboration, we think that is key to collaborate. So to be feasible, a biorefinery project has to bring together and align many actors from different sectors. These collaborations require new business agreements and strategic alliances to join ventures that are not always easy. This means that in the bio-based industry, you will find from universities and research centers to different companies, also the primary sectors, also the different end users which are already in the market. So it's a whole heterogeneous series of different actors that needs to be aligned and work together, and each step of the value chain needs to have their advantages in order for the whole value chain to work together. So it's key to find these new ways of collaboration and these new business models that can make the whole value chain to work together and in a harmonized way. Then something that was also pointed out before is that we need to be competitive regardless of the model. What we mean here is that bio-based products must be cost competitive regardless the sustainable aspects. So in order to enter the market with warranty, especially in B2B markets, what we want to express here is that the market, even if especially the final consumers, so people, sometimes they are willing to pay a little bit extra money for bio-based and sustainable solutions, we should go for competitiveness. So we should work in being competitive at cost in order to fight with the fossil-based solution. So this is key, especially in the B2B sector, because normally when you sit in the table with a purchase manager of a company, they are very, very much conscious about price and cost. And normally, even if sustainability is nowadays gaining more importance, but it's something extra, but it cannot be the only way of convincing people to move to sustainable and bio-based solutions. So we should go for cost competitive models. Also, it's key the market knowledge. So it's important to involve in the business model actors who are already operating in a target sector, ensuring the market access. This is critical in innovative products or market niches that are difficult to enter. What we want to say here is that if you want to create, let's say, bio-based chairs, you better speak to IKEA to enter the market. If you're finding a new bioplastics for the industry, you better go hand by hand with a plastic commercializer buyer, because they normally know both the channels and the ways to enter the market with warranties. And normally, the technology providers, sometimes they do not know the market as good as other companies. That also goes together with what I mentioned before about the importance of collaboration, building together models that are more feasible. And finally, we have to take into account and be conscious that biorefineries require long maturation times and sometimes important investments in R&D. But when you reach the final step, you can be very, very competitive and have really success cases for the market. That's all from my side. It was a pleasure to be here. You have my contact details in this final slide. In case you want to get in touch with us for further questions or further collaborations or any other issue. Thanks a lot. I give you back the floor, Mariana.
Thank you very much, Jose Maria. It was truly a pleasure to have you all on board. I don't see any questions to the speakers. We still have 2 minutes more. If you would like to ask something else to the speakers, if we don't have time enough to answer, that will be done after this session by email. And just a reminder, this session was recorded and will be shared afterwards to the email addresses you provided us when subscribing to the webinar. Thanks again to the speakers today to have the opportunity to share with us all your knowledge, and also to the participants to be together with us this whole session. Thank you all very much and see you, I hopefully see you soon. Don't hesitate to follow the BioSwitch project on bioswitch.eu in case you are interested in knowing more how to switch into bio-based. We can see on the chat one last question. Well, thank you very much, Anna, for taking the time to send us a comment. And there's a question from Vincent Farelli. What is the impact of rising energy costs? I don't know who would like to answer that question. Anyone of the speakers would like to answer that question from Vincent?
Well, I think the impact of raising energy cost would be the same for bio-based industry and standard industry. It's a problem for all of them. And it's a big problem because production requires energy. So that's probably maybe an input for bio-based industry, because during my presentation I showed that company Chiesa, who produce cutting from tomato, they also have a big anaerobic plant where they digest the waste from tomato, potato, onions, and they get from the anaerobic digestion enough biogas to run all the factory, all the farm, and sell to the Italian provider the energy. And they are making almost more money from the energy production than from all the farm. And the countries such as Italy, Spain, many Mediterranean countries can really have a huge biogas production from biomass. And this is something we should consider very seriously, because it will be a step to be independent from importing gas from other countries, while we can produce the gas degrading our huge agricultural biomass if properly organized and conducted.
Thank you very much, Patrizia.
Can I add something, Mariana? Relation
Sure thing. Please.
Yeah, so I think that as a continent, EU, we shouldn't hide our heads in the sand. Yeah? And indeed, the question from Vincent that I know very well, and I want to say hello to him. It's fair, yeah. There will be an impact, yeah. And also the EU member states should be very aware that also a tax shelter or an appropriate tax incentive should be put in place, yeah, for that. Many times companies, they issue strategic choices based indeed on the cost of the fossil fuels, yeah. And this is really the right momentum to start thinking about how to boost the bioeconomic sector for biofuels. Yeah. So Vincent indirect, let's say, statement is perfectly correct. And let's have a look, a continuous look to what is the price of the fossil fuel price, and if we want to sell an innovation or to propose an innovation to potential investors, let's always try to make comparison and also to raise the awareness of the public administration, which should help on that. Yeah? In Germany, in my personal experience, I worked in Germany, and there are many municipalities in Germany that apply tax sheltering policies, yeah, to plants producing biofuels. So if you are able to demonstrate that you are disposing in a correct and sustainable way a waste, yeah, then the municipality applies a tax shelter. So you don't pay, for instance, municipal taxes related to waste or to pollution. So it's important also that public administration will play its role in that sense.
Thank you very much, Angelo, and the rest of the panelists. I'm afraid we are running out of time. So thanks again for being here today. It was a pleasure to have you on board. See you next time.
Thank you very much. Bye-bye.
Bye.
Bye-bye. Thank you. Bye.